Now we're going to take a look at arithmetic series. So once again, the word arithmetic means we're dealing with sequences where we are adding or taking away for each term. And the word series now indicates that we aren't just going to have a list of numbers. In fact, what we are going to be doing is adding together every number in that list. So if we take our basic sequence of 3, 5, 7, 9, 11, 13, this is an arithmetic sequence. It's just a list. We make it a series by adding all of these together and getting a final result. Now, we can choose how many of these we want to add together. We could add just the first 3, the first 5, or we could add an infinite amount of them. For that, we'll come back in another video. But for this one, we're just going to have a look at when we are adding a finite number of items in a sequence. And we're going to learn how to prove the equation for this. Okay, let's have a look at how to try and prove this formula. There's a funny story actually about how this formula came about. Apparently, there was a mathematician in a bar who was bet that he couldn't add all of the numbers from 1 to, I think it was 100, in under 5 seconds. And the story goes that he had created this formula and used it to get that value, and he got a free pint or something. But no free pints here. We're just going to work out how we're going to prove an equation for this. Right, step 1 is we're going to algebraically write out all the numbers in an arithmetic sequence and then add them all together so it'll be a series. So I'm going to call this S, the sum of these values. Well, the first value in an arithmetic sequence or series we know is A. The second value is our first value plus a number. And if you remember, that number is D. And then the next one is A, it'll be a plus though, A plus D plus A plus 2 times that difference, keep this bracketed, plus A plus 3D, and so on. And the final value that I'm going to be interested in will be A plus N minus 1D. Running out of space there. This is just proof from the last video. Now, what I'm going to do is something that looks a bit weird, but it's these little tricks that are generally how we get these equations in the first place. It's what a lot of maths is, trying to work out where our tricks are. And what I'm going to do is I'm going to write out this exact same sequence backwards. So I can add a sequence or a series either way I want. You know, it's going to give me the same thing. 2 plus 3 plus 4 is the same as 4 plus 3 plus 2. So I'm going to write out the same thing backwards. So I'm going to start with A plus N minus 1D. I'm then going to add on to that. Well, the next term down from that would be A plus N minus 2D. All the way down until I get to these values again. A plus 2D plus A plus D plus A. And now what I'm going to do is I'm going to minus these equations from each other. Okay? I'm going to now what I'm going to do is I'm going to add these equations together. And you'll see why in a second. So if I add all of these elements here, well, let's start off here. An S and an S, well, that's 2S, so 2 times my total sum. Okay, now let's add these 2 terms. So A plus N minus 1D, well, that's going to be A plus a load of stuff. A plus A is 2A, so 2A plus N minus 1D. And then the next 2 terms. A plus D plus A plus N minus 2D. Okay, that's a bit trickier, so I'm going to write out the full thing. A plus D plus A plus N minus 2D. Okay, well, I've got an A and an A. That's going to give me 2A. And then D plus N minus 2D. Well, if I do want to expand this out, so I expand this out into nd minus 2d. Then I can have d minus 2d, which is minus d plus nd. I can factor out my d, and I get 2a plus n minus 1d. Okay. Well, let's go all the way to the end. And we see that this here is the same as this one, which means a plus n minus 1d plus a is going to equal here. My next one up, a plus d, is going to add on to, I haven't got it written here, but a plus n minus 2d, and so on. I can match up every single one of these series. I can match up every term in these series, and I will always end up with 2a plus n minus 1d. I've seen it here, I've seen it here. You can test it for the rest of them, or you can take my word. I will always end up with 2a plus n minus 1d. So when I add these two together, I end up with a sequence, or a series, that is 2a plus n minus 1d, plus 2a plus n minus 1d, plus 2a plus n minus 1d, over and over and over again. Now, how many times am I adding that together? Well, it depends on n, right? It depends on how far into the series I'm going. So I can say that what I'm really doing, I've got my 2s still from here, is I'm adding this to itself n times. I'm multiplying it by n. And this tidies it up a lot. Remember, s is my sum, the value that I'm after. So to get it on its own, I can divide by 2, and I get my final expression, n over 2 times 2a plus n minus 1d. And this here is the equation for adding all of the terms in an arithmetic series. Just before we see this in action, I want to just draw your attention to something going on in here. Now, if I expand out the interior here a little bit, and I just split this into an a plus a. So split my 2a into a plus a, keep my n minus 1d, I notice something. I notice that out of nowhere I've pulled an a plus n minus 1d. Now, hopefully from our last video, from our previous study, we recognize that this here will be the equation for the last term in a sequence. So my sum, in fact, Sn, is n over 2 times by a plus L. My L's are weird. That looks like an E. Yeah, gonna have to get used to that. A plus L, the last term in the sequence. So if I know the first and last term in a sequence, and I know how long the sequence is, I can add all of the terms in those immediately, without even having to bother with any of this. And this is how that story of the guy in the pub, if it's true, would have happened. He would have had this formula here, and if you wanted to use this to add all of the numbers from 1 to 100, well, n, there are 100 numbers, over 2. A, well, the first number is 1, plus L, the last number is 100. You end up with 100 over 2 times 101, which is 50 times 101, 5,050.